Hello everyone. Hello everyone. Welcome to the live session of Science Data Science. Today I am going to discuss about the methods to check importance of the features, or you can say feature engineering as well. Like either you are a beginner or you are a professional. Yeah, this video is live session is going to be helpful for everyone. If you are a beginner, it will tell you how you can select the specific feature for your model building, because sometimes what happen, we have a lot of features, right? We don't understand which feature is going to be important for your model building. So this is the very important topic, and like many students ask this question, so that's why I'm doing this live session. So let's start. Here you can check, like the first one method is correlation matrix. So this is the very important method to check the selection of the features, like which feature is going to be important for your model building. And you can do this before building a model as well. This is the most popular, most common method from the pandas library. And it's very easy to check whenever you start the database, like the analysis. You do some like the basic steps, like the steps. First, you will check the how many features you have in the data set, and then you go with the duplicate check, missing value check, and then next you check the correlation, which is very important. Correlation, what is the definition of this? Correlation means you are going to check the relation between two features, either with the target or either if the independent variables are have a strong correlation with each other, which is not good for our model. So in that scenario, we need to take care, and wisely we need to select the your how which feature is going to be beneficial for your model. So let's start in the detail. So first of all, you need to import here pandas as PD, numpy as a np, and your matplotlib as a this one. Okay. So in this case, this is you are importing the all libraries which are mandatory. Here, just give me 1 second. All right. So now, first of all, we will import these libraries which are mandatory. Okay. Pandas we use for data manipulation, and NumPy we use for over calculation, mathematical calculation. Matplot and Seaborn we use to draw the graphs for the data visualization. Here I am taking the house sale price data. This is from Melbourne housing data. So I picked it up from the Kaggle. If you want, I will share the link in the description box. You can download it and you can apply the same methods on your this data set, and you can apply more methods as well according to your requirement. And now look at this. We are downloading the data set here. So this is our data frame, and we are reading the CSV file of the Melbourne house. So correlation only and only work for the numerical data. It doesn't work for your categorical data. But if let me run this one, and I'm using the Google Colab. Here we will upload the data set now. Here we go. Right? So we have the data set here now. We will run it and load it again. Now, if you want to look at these, how many features you have, you can do like this way. Okay. So it is going to show you the first 5 rows in your data set, and you can have the just little bit overview, what type of data you have, how many features you have. So you can have the just idea about your data set. Now, if you want to look for the data in detail, like how many categorical object, and your other features in your data set. So here you go. Info method is the most popular method we use to check the missing value. Number one, it will tell you like how many entries or rows you have in your data set, and it will also tell you like what data type you have in your data set. Like this is the first year feature, its type is object. Address feature, its type is object. And then you have integer, this is your number of rooms in the data set, and then so on, right? So this is giving you the complete information. This is very very useful. If you are a beginner, this like the method is going to be very very helpful for you. And now you can also can have the here, keep an eye on this. Look at this. Your total records are 13K580, but it is only your 8,205. So this means there are a lot of missing values. So this small method is giving you all information. Okay. Now I know how many I know how many data types exist in my data set. Now my next goal is to check about the correlation of the features, so I can decide like which feature I should keep in the numerical data type, which features I can drop based on the correlation, like in this your data set. Now, first of all, before checking or draw the heat map, I need to separate my numerical data from this data set. If you are going to apply this on the whole data set, then it will create a problem for you because this is only work for the numerical data. So how would you do that? You will declare here one variable. This is you can declare with any name. I have represented with the numerical underscore data because I am going to separate my numerical data integer data type from my data set. So I can check the correlation of all integer data type with the target, and if they have the correlation with each other as well, which is never like a good for your model because it is known as multicollinearity, which is not good for our model performance, model building. So here we will do df dot select d types include number. So here this is the code you can write. It will separate out your all numerical data. If you want to look at this one, we can cut it and paste it in the next line. Here we go. And here we can paste over numerical data. So you can see it is only showing you the numerical value, right? It is not showing you anything else, no categorical. So our data is ready now to for apply the correlation method. Now I have declared the variable correlation matrix is equal to numerical underscore data dot correlation method. This is from the pandas and this is inbuilt. You don't need to do anything, and just we will check it. If you want, we will print it if you want to see the values of this one. Now look at this. This is showing you the like the insights from your numerical data. Look at the all features. This is showing rooms, price, distance, and so on. And here it is as well. Look at the values here. Let's pick up the value of rooms here. This is one. Diagonally, if you see, all values are 1, 1, 1, 1 because every feature is highly correlated with itself. Okay, that's why it is showing 100%. And if we check the relationship of the rooms with the price, how much? 49%. If it is a not negative value, this means this is going to be your positive correlation. And if you found the negative value, this means this is negatively correlated with your that feature. And here in the numbers, if you found any number above the your zero point 0.9, right, or 90, this means those features are highly correlated with each other. It can be like, for example, if your room is highly correlated with the price, because what is price? Price is the target of your this data. We want to predict the house sale price based on the given feature, but today our goal is not to do the prediction. Our goal is to select the feature according to our requirement, and so we can build a good model. So here you can see this is a negative correlation. This is the way how you can check one by one, have a like a overlook, right, about the correlation of the numerical feature with each other. But I will show you with the map as well. This is very easy to analyze instead of just looking at the numbers. So now we will draw the heat map. Heat map is very popular. We use this to check the correlation in your data set. Here we are just drawing the plot.figure. This is from our matplotlib library. This will how big graph you want to draw. And then we are using the SNS heat map. So here I have passed the correlation matrix result, which we have calculated here. And then annotation is true means it will show you the percentage on each your the square box. So this is a just palette. You can change it. There are many palettes available in the Seaborn, so you can pick up anyone according to your color choice. Okay. Format means like we want to show the decimal after decimal only two numbers. So that's why it's 0.2f line width. These all are customized. So you can make a changes in this. And then we are giving the title correlation heat map. And then this is your graph. Here look at now these features. So this is showing you all numerical features, rooms, distance, and so on, right? Look at this diagonally. So what is going on here? This is means this is all features are correlated with each other. Sorry, with itself highly. That's why it is 100% because every feature is related to it, correlated with itself 100%, right? And then if we look at this carefully, rooms, this is a highly correlated above 90% positively correlated with bedroom 2 as well, right? And our target feature here is price. Okay, that is fine. But if your these two independent feature means features which you are going to use to predict the house sale price. Okay, and these are highly correlated, which is not good for our model. Because if I am going to take an action on the any on the bedroom to if I record like do this, then it may like the affect your other feature as well. Now, if we check about the bedroom 2 here again, you can see here it is also showing the hair relationship. You can read it diagonally as well. You can read it like this way vertical and this way as well. Okay. Now on the right side here, more red color means 100% correlation. Light color means in between 40 to 50, right? And the lighter colors, blue one shows less correlated. You can see here the negative correlation as well, like this. So price your this year bit is negatively correlated with your price, right? Only 32%. So what does it mean? Positive correlation means like this way. If like you have this one, your one feature. Okay, this is your let's say price. Okay, and this is your second feature. Let's say this is your we can keep price. No, we will take the rooms and bedroom too, right? If this is the room, this is the bedroom too. If this is increasing like in this direction, this is also going to be increased in this direction. So this is called positive correlation. But if we talk about the negative correlation, what will happen? And now we will take an example of this one. Here we have, let's say this is a 32% negative correlation price, right? So this is your target and this is your year built, age of the house, how old the house is. So now if the price of the your house, right? If the year built of the house, age of the house will increase in this direction, okay, the price will go in this direction. They are in the opposite direction. Okay, that's why it is a negative correlation. In short, if the age of the house is like the you can say newer, right, the price of the house will decrease. If the age of the house is older, it's like 30 years old, 40 years old, the price will increase, right? So this is sorry, yes, this is will increase, right? So this means they are working in the opposite direction. One feature is increasing, the second one is decreasing, right? If your house is recently built, only 5 year old, right? So this means the price will decrease. So all are in the opposite direction. So this is called negative correlation. Sometimes you don't have any relation between the feature. It depend upon the like your data. So it is giving you the clear picture which feature should you keep, which feature you can drop. Okay, which are highly correlated with each other. Definitely we can delete one of the feature, right? Because this will create the multicollinearity and it will may harm your model performance. Your model is not going to learn too much for these kind of the features. Okay, so here we go. How would you do that? Find highly correlated features. This is greater than your 90 or less than your 90, negative correlation. So we are writing, we have declared here one set. This is data type, and then we are running the for loop on the your till you have the column in your correlation matrix. We are using length, method, and range, and then we have entered the j. This is the nested loop. For j in range, whatever value column is selected from it, it will pick up absolute method, and then it will check the correlation with the first row, first column. If it is greater than 90, then it is going to collect it. Entering the column name in this, it will collect it. Okay, and then it is adding those feature into the this like your set, which we have declared here. Why we declared the set here? Because I don't want to duplicate my feature name. Okay, and then so it is showing us highly correlated features to draw bedroom too, as you have already seen it here, right? This is highly correlated with the rooms, because if I'm only looking for the bedroom too, now, right, if I drop the rooms can be on first floor, ground floor, second floor, but if you delete the bedroom, it will not affect too much. Why? Because room has the plenty of information how many rooms in your house, but bedroom only has the information how many bedrooms in your house. Okay, there will be the guest room, it is not bedroom. There will be the one other bedroom like your living room, right? So that's why we it is choosing this one, and we can drop it. So you can see now how easy it is using heat map to check the correlation, high correlation with your here the features in the data set, and you have now clear vision how you can drop this feature without any like other taking any like the decision which is not relevant to your data set. Okay, sometimes what we do, we just look at the data set, we think like a layman, I am going to drop this feature. This is not good decision, wise decision. Always follow the proper strategy so your model should be good. And then we will drop it. Now here, this is your new data set. Okay, so this was the first method. Now we will move ahead with the second method. This is univariate statistical test, which is very like the important as well. And because your data set is a combination of categorical, numerical, both features, and your correlation only working for the numerical feature, but you also want to check for the categorical feature as well, right? So this is also important for you, which feature is going to be important. This is very like the important question, and most frequently this is a question come up from my students, like how we like check if categorical feature I should keep this or not, and it's very hard as well to decide about the categorical. So now I will make this thing for easy for you. Here we will check based on the p-value. Okay. If you have the low p-value less than equal to 0.05, this is the like threshold value given. This is inbuilt like we are setting default value for the p. Likely important, keep it unless redundant. Okay. In this scenario, if value is less than this, extremely low value like it is going to be like 0, then you can check for redundancy and drop one feature. Okay, but if your p value is greater than this, then feature is weakly related, like a weakly related to each other, correlated. then you can consider dropping. Okay, so these are the the facts about the p value. If you are clear with it, then you can do the calculation, and then you can decide. This is going to be very easy for you. Okay, so now we will come here. So I have imported the collections ABC for values view. I'm using this library for applying during the method. I will show you where we are using it. And then you have a SciPy stats. This is chi-square method. This is very important method. This is you are going to check your p-values using this chi-square method for categorical features correlation. Okay, and then you have a sklearn pre-processing label encoder, because to calculate the your p-value, you first need to convert your categorical data into numerical. This is important. Okay, and then pandas. If you don't import the pandas here again, it's okay, because we have already imported above. And then we will now use the same method as we did with the numerical. You can choose the select data type object here. Okay, and then categorical data is equals to categorical data dot apply label encoder method. This is inbuilt library which will convert your categorical data into label encoding. Okay, it will assign the values to your all your categorical feature. Okay, and then fit underscore transform means it will fit onto your that data frame. Okay, transform it from categorical to numerical and then fit onto that, so we can use it further. Now look at this data. So it converts your all values into this. Okay, and label encoding, it will just use like a 1 2 3 4 5, like maybe address, it is picking up your this number type. It is a type of your, I think, whether it is a flat or it is an independent house or it's a double story. So maybe there are a 10 unique category or 5 unique category of the house. So it will label it with the 0 1 2 3 4 5. This is a label encoding. Okay, and then method and seller and so on. It will automatically assign the category number to your each categorical feature. Okay, and then what we are going, this is our process will start here. So you have your contingency underscore table, and then we use the pandas library instance cross tab categorical your data and address and categorical data sub your sub arb. So this is why I am taking here two features, because your cross tab, your this function check the correlation between two features categorical, because the over goal is to keep the feature only which is highly correlated with the target. We are not interested to keep the feature which independent features are correlated with each other. So we are going to do the comparison here, right? With the independent features. So we picked up, you can pick up any value. I have picked up this one. I am just checking the correlation of address with the suburb. So now these are the four the parameters of your this chi-square contingency method. Okay. And here we have passed the table, which we have made it here. Okay. So what is this? I will explain. Your chi2, this is a chi-square test statistics. This is the result of the test, which tells you how much observed value differ from the expected value under the null hypothesis. Okay, because if your value is p value is your, look at this, the p value associated with the test, this tells you the probability of obtaining a result at least as extreme as one observed, assuming the null hypothesis is true. Then you cannot reject it. Okay, in case it is not true, it's a false, in that case we can ignore it. Okay, or either we reject it. Now DOF is your the degree of freedom associated with chi square test. This is calculated rows minus 1 and then multiply column minus 1, because it is going to work on your each row, each column by checking the relation as you have seen in the heat map, right? And then expected a 2D array containing the expected frequency of each cell of the table. Now your table contains two columns, right? Two features. So it is going to check each and every value and then it will give you the result. Now if you run this result, it is showing you the chi-square statistic value, this one, and this is your 3.998 p-value. So it is greater than your what? It is greater than your 0.05, right? This value. So in that scenario, what decision we need to take? Feature is weakly related, consider dropping. Okay. So this means if this feature like the suburb is related to this one, right? High correlated or weakly correlated, right? Then we can drop that. Okay. Highly correlated means with this feature. Okay. If it is weakly correlated with the target, even then you can drop it. Okay. So it is showing us, it is like if these are highly correlated, we can drop right now this one. Okay. Because, sorry, not this one, we will drop this one. Okay. Because in your city, you have the many different address, right? But suburb has the full options for like the complete address for your like the house. Okay. So now we will move ahead here. This is, we will see now, we will check it here what decision we are going to take it. Here we have written the code for the like how you iterate over the each column and check the your p value for each column and the relationship between address, suburb, and you have other columns as well. You have the type, method, allergy. We will check one by one each relation. Okay. So for that, we are going to use here your p value threshold. We have set it 0.0001. You can change it, but we will set it right now p value like the minimum one. Okay. Because dropping a feature is not a like a very easy decision, because we don't want to lose the data as well, but we don't want to use the feature as well which is not more beneficial for our model. Okay. So now we will like run the loop over this column 1, column 2 in the combination. This is your categorical data dot columns, right? For 2 columns. And then we will create here your table cross tab categorical data column 1, categorical column 2. Now we are just taking the general name. We are declared the variable in the your for loop. It will run over each your categorical data frame, pick up first like the each column, sorry, and then calculate the p value. So here we are checking, and then if p value is extremely low, consider one of the feature redundant. Now your p value, what threshold you have set here, it is calculating the p value here. It is going to be compared with this one. Okay, so which p calculated value from the columns is less than your threshold value which you set, right? We will decide to drop those features. Okay, because those have a weak relation with the target, and then we can drop them. Even if they are highly correlated with each other, you will come to know because their p value is going to be very high. Okay, and in this you can see here is the list of your all values. This is between suburb and address. P value is 3.9. We have calculated it earlier. Then you have a suburb with the type as well. Its a p value is 0, right? So now what decision you will take here? We will look at the bottom. Okay. So this is for the all, how you can check the apply the chi-square testing, and you can suggest now it will suggest you the all features which you can delete. Here we go. Council area, type, date, region name, address, allergy, method. Okay. So this is telling us you can go deletion with these all one. Okay. If you check the council area, we can go here. We can check the council area. Here we have 0, right? This one, and allergy with the date. This is the value. This is very high, right? So it decided it itself. Okay. By doing the calculation. So now you can drop these all features. This is suggested by your chi-square test, okay, according to the p-value and your chi-square test value. So we can drop them. Here we have delete this one and then this one. Here we will like this. Okay. So now here, okay, sorry about it. I have uncommented this one. This is the comment box. Here we go. If you want to look for the simple one, so we can like do it here like this. Okay. So you are left with this one. So now we have made the changes in our original data frame. Okay, but I did not update yet the numerical data. You can, but this is updated with the your categorical features which we don't want. It is dropped because bedroom 2 is still here because I did not update my original data with the numerical feature which we have dropped. Okay, you can. So now this is just we are using the DF info again. And till so far, now you have the knowledge about the numerical data. You can use the correlation method. Second is your chi-square method and p-values, like based on the null hypothesis. In what scenario you need to reject it if the p-value is your greater than 0.05, right? Because its range lie between 0 to 0, your 0.5. Okay, here we can go back. Check here 0.05. Okay, so these things you need to keep in your mind and rest will be okay. Okay, and now we will move ahead with the next method, feature importance from tree based model. Okay, this is not specifically for your like we will say, like you can apply this method on the whole data set. Previously you have learned about the numerical and categorical. Here you can pick up the whole data set. Random forest is a very like the good algorithm model which take the decision based on many conditions. It keep on creating the like based on the yes no more trees, and when it is finalized like now next there is a not possibility of like this case is going to be continued, then it will stop. So it will give you the best results. Okay, this is also one of the method. If you don't want to apply those one, then you can choose this one. Okay, and then for these you need to first import the random forest classifier. This is the from sklearn. This is an ensemble model. sklearn data set we are using here, iris data set and pandas matplot. Now we will load the data set, and this is your data set, and this is feature name. We separate the target and column, so your independent feature. Okay, and now we have prepared the model, fit the xy on the model, and now you are going to use a inbuilt method feature underscore importances underscore. This is inbuilt. Okay, this is going to show you, sorry, which features model has used most oftenly to predict the value. Okay, so in this here we are going to use this. If you run this, it will show you all your features based on its importance. If you look at the bar graph here, this is the feature importance, right? This is petal length, petal width. You can see your petal length has a mostly used by your feature, right, during the prediction, because this is has the higher frequency than other three features. It is showing you the importance of the feature for the model, right? And then it is your petal width, it is little bit less than, but it is more than this. So for according to me, these three features are good, right? But this feature your model used rare. It has a very less frequency, right? It is below 0.1, below 10%. Okay, so you can see now how easy it is using your tree based, like the tree based model using just simple method tree underscore importance underscore. It will tell you the importance of each feature, which feature your model is most often used during its training. Okay, for the prediction. And then we will just plot it in the like the user friendly form. This is the feature importance. Then you are this one, and then we will look at it here. So now look at this output. So this is here petal length. It is 43%, and petal width 42%. Sepal length is your 0.11%, and sepal is your 0.026%. Okay. For this one, they are saying there is a no low importance. Okay, so why? Because we have set here some threshold value. This is the threshold of the features. Okay, if it is less than that, I have set the threshold value 0.01. If it is going to be less than that, then I am going to drop this feature. Okay, now this is you need to do the testing. First you have the feature importance. It's very easy for you, but now you will set some threshold value because you want to save the data as well, right? But you got an idea what I need to do, right? Because if you look at these, this is zero point 0.1, right? But it is not completely zero as well. It is somewhere around here 0.001, or you can say between 10%, 0.2 or 0.002, something like that. Okay, and then we will set this threshold value. It is not going beyond this. That's why it did not say us to delete this feature. Okay, so this is the way how you can use the tree based random forest model as well for the feature selection. Very easy way. First you use your declare, apply the model, then pick up the, use the feature underscore importance underscore method, and then just set the threshold value, and then just decide. Okay, you can play around with the threshold value. We start with the minimum value. Okay, it is not mandatory for you to, you just to stop it here. If you want to debug more and there is some other exceptional requirement for your data set, then you can increase it. Maybe you have a 50 features, right? Many features are below 0 point, let's say coming up to 0.01, right? Which is does not seems to be useful for you. You can keep on changing the threshold value. Here the most important thing is this thing, when you are applying, it's advisable talk to the domain expertise. Okay, if you are going to talk with the domain expertise, they are going to give you the idea which feature is important for them. According to that and according to your this, like the implementation, you can take the decision. If you are a domain expert, this is excellent. But if you are not, then this is recommended, like you talk to the domain expert as well. Okay. And now we have a recursive feature elimination. This is also very useful method. This is how it works. You will again train the model for using all features. You will rank the features by their importance like we did in the tree-based model. Remove the least important feature. Least important means like your model did not use that feature much. Okay. Retrain the model using the remaining feature and then repeat until the desired number of features is reached. So this is a workflow. Again, we are using the iris dataset. For this, you need to import feature selection, import RFE. Okay. This is your recursive feature elimination. This is very popular method again. Now we have separate the independent feature and target and logistic regression we are applying on this, and then apply the recursive feature elimination. So here, this is the model. This is your instance of your RFE, and then number of features to select 2. Okay, we only want to select the 2 feature, and then here your 2 features are X and Y, independent and target, right? So then it will work on this. Print the selected feature X dot columns fit dot sport under. Okay, which features are sporting from your independent feature. And then for your here, the drop the unselected feature, it is saying drop the unselect like the features which is not supported by model or which feature model did not use. It's a straightforward. Okay, so now look at this. So selected features, your model, if you are applying this method, it selected only petal length and petal width, and these are the only two features from the iris dataset. Now you can see the difference, right? Tree model based, when you were setting the threshold value, it was telling us no feature you need to drop. But when you are using the recursive one, we are not using here any threshold value. It is working itself at the back end. It will keep on checking your like the feature, which feature is used by model, and then give you this result. Now, maybe you are thinking which method is going to be useful for you. Again, I will say you need to talk to the domain expertise here as well. Okay, because you have a knowledge of now all methods, most common methods, how you can choose a like do the selection of the features for your model building. Okay, but here if you're talking to the domain expert, it will be really very helpful. Okay, and now here the next method is your variance threshold. So what is variance? Distribution of the data, right? So low variance features which don't have a much distribution. Purpose: features with very low variance are unlikely to provide useful information for the prediction. Okay, so they can be dropped. When to use? When you have a features with the low variability. Okay, when there is a like a no too much distribution of the data, variance is low, right? At that time you can use this method. I have also mentioned in the above method as well when you should use which method. Okay, and then here we will again using the iris data set. Here we feature selection, you need to import this library, variance threshold. Okay, now we will create the data frame with your features, compute the variance of each feature. Again we are using the minimum value 0.1, and then select fit on this selector variance. It will print us the variance through the graphical representation. Here we are just saying identify low variance features which is less than this threshold value. Now look at this. So what threshold value you set? 0.1. Do you look at this one now? Your sepal length, sepal width, petal length, petal width, right? It is not like showing you between 0.1, right? All features are above this. So this means this method is saying you like you don't need to drop any method because its variance is low even, right? So we when you are like dependent on the by checking the variance of the data features, then you can use this method. You can set up the threshold value, right? This is the default value which we have set. You can try with the other as one, but keep in mind domain expertise help is must. Okay, and now the last one is your pairwise feature plot. This is for categorical and numerical both features. Okay, in this purpose, pairwise plot help visually inspect the relationship between feature and the target variable. Okay, here previously we were checking the correlation with the independent feature with your target as well. You did the categorical, we were checking the relation between the independent features only. Then you did the tree based. The next one, again it was checking with the checking the variance of the data, right? Not the correlation. So here we are checking the your all features correlation with the target. When you want to visually explore the relationship and identify the patterns that indicate which feature might be important, at that time you can use this. Okay, so here we have import the libraries. This is all like the very well-known libraries. Here we have set the target species, and then we are mapping the numeric target labels to species name. What type of you have Setosa, versicolor, and virginica. We have three these, right? This is your target variable in the iris data set. based on their sepal length, petal length, sepal width, petal width, right? We decide which type of the species is this. Is this Setosa? Is it versicolor or is it virginica? So that's why we are showing it here, okay? And the correlation matrix, we are just calculating the correlation matrix. We are separating the categorical and just picking up the from the last one and visualize the correlation matrix here, and then we are just checking the relationship. Check the highly correlated feature with the 90%, okay, because we are checking the correlation, that's why we are setting it 0.9. If it is above 90%, then you are going to use it. Then we are length highly correlated with the target, okay. Here we have write the code for this one. This is using the for loop. Here it will pick up your like the each column row wise, if it is not equal to this one, right, and then it is making the pair. Like it will pick up from your like the data frame iris, your first column, first row, value of the feature, compare it with the your next one and create the pair of both, okay. And then we are just collecting the here highly correlated pairs which is greater than 0.9, and we are separating here over x and y, then applying the random forest classifier on these. Here we are just showing the again using the feature underscore importances. And now look at this. This is the heat map which we have like the right here. This one. So it will show you visually. Now look at this. This is your sepal length. This is sepal width, petal length, petal width. On the right side, it is showing you dark the red color, highly correlated. Little bit light, this is 50% correlated, 40%. If it is going more lighter and going down, this is negative correlated because this is starting from here 0, okay. Now we will check for the sepal length, how the sepal length is connected with all other feature. With the sepal width, it is just negatively correlated 12%. If this is increases, this is not going to like increase in the same way, okay. So one feature is like this, other feature is like this. If this is going up, this is going down, okay. And then you have the with petal length, it has a good relationship, right. And this is also good, but this is not something alarming. We are looking for the red color, okay, and we will come here. Petal length, look at this, 96% it is connected with your petal width. The independent features are highly correlated with each other. It is also like related with your petal length because each feature is correlated with itself 100%. And then sepal width negative 43%, then 87%. Again with the petal width 96% with the petal length. So it is showing you very clear picture, right? How they are correlated with each other. Okay. And now we will come here. Look at this. Highly correlated feature pair is petal length and petal width. We have already seen it, right? Petal length and petal width. We know, right? Graphically it is showing petal width and petal length there. So if you are going to delete one feature, it is going to affect the second one definitely, right? Sorry. So here, this is just showing the importance of all features for the your model. This is petal length 43%, petal width 43%, this is 10%, and this is 0.02%. Very less, right? So now look at here. Okay. So now in this, what you will do, what decision you will take, whose relationship is greater than 90% independent feature, you are going to drop that. Okay. But you also need to check here, like this is also important for your model as well. Okay. So in this scenario, again, you need to talk to the domain expertise as well. Okay. Because there is problem when your two independent features are highly correlated with each other. This is called multicollinearity. We need to give the solution to this problem. Okay. So now this was all about over like the today's live session. You have learned how many methods? Six methods for this one. And only you need to check your correlation matrix method you will use for numerical data to check the linear relationship going in the same direction. And the second method is your univariate statistical test, chi-square test, p-value test. And when you should use it, this is when features that are not related to the target are less important. When to use for categorical feature, when you need to test the relationship with the target. Okay. And then you have the next one. This is the one when you should use this one. Here, these models can handle both numerical and categorical, right? This is like a feature importance directly after your training. This is the best way because when you train the model, you will come to know at the back end which features your model has used most of the time, right? There is a more libraries which we use that is called SHAP library. I will explain it in my next live session in detail. SHAP 1. This is very important and we use this library only after model building. So next time when you train your model, you can drop this feature to make your model performance more good. But I have told you the two methods today as well. This is random forest and then your recursive feature elimination as well. Okay. And the next one is was your variance threshold to check the variance of the feature. Okay. And then you have the pairwise feature plot. This is also very important. Just picking up the two, like the feature, checking if they are okay, have a high correlation or they have a weak correlation. This is if an independent feature have the don't have a strong correlation with each other, this is a good sign for our model. Okay. And then that's all. Okay. So now if you have any question, you can drop the question in the chat, right? And just let me know if which method you are going to apply on this. Okay? And thank you so much. I will see you in the next live session. Thank you.